How are y'all doing? My name is Brant Dykes, and we have done the wind turbine project. Later on in the video, you'll see me talking about the improvements that we could make on this project and also what we concluded. Thank you.
Hi, my name is Abhilash. I'm the calculator of this group. Later on this video, we will do some mathematics.
Hey folks, my name is Alex Brandt. I'm captain of this group, and I'm going to talk to you guys about the results and how we got them.
All right, hello everyone, I'm Justin. I'll be giving a brief introduction, hypothesis, and a setup for our experiment with our wind turbine. Our objective was to create a laboratory to explore wind energy. We were focused primarily on the effects blades have on wind turbines. We looked at the types of blades, pitch angle, the number of blades, and we conducted multiple experiments in order to gather necessary data. For our hypothesis, we don't think that the pitch is going to affect it all that much. The different blade types probably will, and also the number of blades. So for our setup, we used a wind tunnel to create the wind, calibrated using an anemometer. PS2174 is the model, recorded our wind speeds. Next, we used a FCJJ29 wind turbine for our actual experiment. It's capable of running 12 blades. We ended up running 3 and 4. The 3 types of blades it has is a custom 28, the NACA 44 and 63. We ended up going with the NACA 44 and 63, and we also had different pitch angles, which were 30 and 60 degrees. Oh, this is our setup. As you can see here, this is our wind tunnel, and it was set up 48 inches away from our actual turbine. Once you powered it up, the wind blew over the turbine. We had 3 different speeds on this. We did 2 turns, 4 turns, and 6 turns.
Wow, that was interesting. I'm going to talk to you guys about the results and how we got them. We had to measure a couple of things. First, we had to measure the speed of the wind as it came out of the generator. Luckily, the computer did it for us. Next, we used an external reader that read the voltage and the amperage that was produced by this turbine. Using all that, we crunched the numbers and we could see how much energy in the form of power was put into the turbine and how much energy in the form of power was produced by the turbine. Obviously, you can't create energy, and in a perfect world that would be the same, but it's not. Here's what we got. For the NACA 44 prop, what that means is the type of the angle it has on it. We got the best result when we used 30 degrees as the angle of the fin, and we used 3 props. Some other notably good ones are the NACA 44 4 prop at 30 degrees and the NACA 63 4 prop at 30 degrees. We'll go over exactly how we got those later on. My buddy Abhilash is going to come show us exactly how we got the numbers.
Okay, and it's me again. Oh, go on.
So what he's going to do is he's going to write down everything. The power out, as we showed in the picture before, is the result in volts and amps, voltage and amplitude. We got a total of 21.59, as I'm sure you can see. He's now going to calculate the power in, which is calculated with a very advanced equation using the velocity of the wind in the area. He's writing it right here. It's going to be 1/2 of the area times rho. In this case, rho is density. That's the density of the air, I might add. He's also going to use the velocity, and he's going to cube it. Once we get these numbers, he's going to plug them into the efficiency equation, which, as in most of your sciences, is power out divided by power in. So for our final answer, we got a 0.5571 efficiency. That's 55.71% of the power that was received through the air was output in the form, like we said, of electricity in volts and current.
You erase it, right? You can need to erase this, so you can just.
Thank you, Avalash, for that informational example. We did have to do a lot of many different types of efficiency calculations. Then again, when we did do 8 total trials for 3 blades, 4 blades, and 2 different pitch settings. So there was a number of trials given. In conclusion, we did learn a lot from this project. We learned a lot about how much power theoretically a wind turbine can produce, and it gives us a good idea of the real-world applications that we see in local wind farms or any engineering applications that involve power output and power input. So, thank you very much.